Nomex is a microstructured product, and more specifically, it is an aromatic polyamide. Nomex heat-resistant fiber grew out of work done by Paul Morgan and Stephanie L. Kolek in the late 1950s at DuPont's pioneering research laboratory. After further work done by Wilfred Sweeney, Nomex eventually became commercially available in both woven and non-woven form in 1967. Nomex fibers were synthesized in response to the fiery deaths of race car drivers of the 1964 Indy 500 and of firefighters in extreme fires. Prior to Nomex, there were a number of attempts to create fire-resistant fabrics using nylon additive substances such as phosphates, borates, and metal oxides. However, these were found to be either ineffective or otherwise undesirable for use on the synthetic textiles, as they had lower melting temperatures and would enter the glass transition state on the wearer's skin under high temperature duress. In addition to nylon-based fabrics, natural fibers like jute, burlap, and leather, following chemical treatments with flame retardants, were used. In the 1940s, during the space race, PBI was commercialized for use in flame-resistant astronaut clothing. PBI, or polybenzimidazole, is still used in tandem with other polymers like Nomex under the commercial branding PBI Matrix for firefighters. Now, Nomex, having been proven to be superior to the aforementioned products, has continued to serve a wide variety of uses, most popularly firefighter gear.
Nomex is highly heat resistant. It undergoes rapid oxidation at around 370 degrees Celsius and turns into friable char as opposed to melting and dripping, which prevents serious injury to those wearing Nomex fibers. Nomex fibers also absorb heat energy. The fiber swells and thickens in intense heat to prevent air movement and heat transfer to the body. Durability and mobility are also key features of the fibers. Above all, heat resistance was the most essential design specification for Nomex polymer, as DuPont created the product because of the need for flame-resistant clothing for people who need protection from fire hazards in their line of work. The Nomex polymer is an aromatic polyamide because the individual comonomer structure of the molecule contains two aromatic rings and an amide functional group, as well as an amine and a carbonyl. The bonding site occurs at the meta position of the arrow-benzene-linked backbone. The production of Nomex is done over a series of catalysts as seen as in this image.
Nomex was specifically designed for flexibility in the workplace while providing the best fire protection. The fabric has an incredibly low thermal conductivity of around 100 milliwatts per meter squared Kelvin, leading to its usefulness in both extreme heat and cryogenically cold situations. The fabric is also structurally stable at temperatures of up to 370 degrees C, with a retention and structural capacity of up to 60% at the melting or oxidation threshold. Nomex was created for thermal insulation, but serendipitously has excellent electronic resistance despite effects of humidity, which will compromise both the excellent electrical resistance and the thermal resistivity. Nomex has shown stability in up to 800 megarads of radiation and will continue to be an insulating material even at higher radiation levels. Nomex is also shown to be fungi, insect, mold, and pest resistant, as the fibers are not readily digestible to living creatures. This image shows that Nomex fibers greatly outperform things like asbestos as well as other insulating fabrics for various voltage endurances for thermal conductivity. Some improvements that could be made to Nomex include the improvements in tensile strength and malleability. While thermal conductivity is by far the most important attribute for Nomex fibers for global applications, the flame retardant characteristics have been carefully tailored by DuPont chemical engineers. Yet strength and malleability of the fibers could be improved in a second-generation version of this polymer product. Due to the method of producing Nomex through a series of condensation reactions of copolymer precursors, the structural capabilities of this metapolymer are lacking compared to Kevlar, which is similar in structure as a parapolymer. As a result, Nomex has a low tensile strength compared to Kevlar, which can provide disadvantages for things like military applications. High melting point plasticizers, such as DPI or di-2-phenyl phthalate, could increase flexibility and strengthen the polymer matrix. In conclusion, Nomex is widely applied for useful applications, including a variety of fields. Nomex fibers have helped save hundreds of lives from the devastating effects of fires.